Hey, hi guys, welcome to this video. So in this video we are going to discuss this problem, unique length 3 palindromic subsequences. Okay, but before we go into the problem, let's try to understand what exactly the word subsequence means. Okay, it's very simple. So if I talk about this particular string, let's say cat. Okay, now please pay attention to my words. Subsequences are nothing but a sequence that can be generated by deleting 0 or more elements. Okay, so this is the string that we have. In order to generate a subsequence of this string, I can choose to delete 0 or more element. So if I delete 0 element, this is what I am going to get, and this is a valid subsequence. If I decide to delete one element, so I got options. If I delete C, then I will get AT. If I delete A, then I will get CT. If I delete T, then I will get CA. These all sequences are a valid subsequence. If I decide to delete two element, so when I delete CA, I will get T. When I delete AT, I will get C. When I delete CT, I will get A. These all are also a valid subsequence. If I decide to delete 3 elements, so empty string, that's what I am going to get. This is also a valid subsequence. Okay, so given a string of length n, you will have exactly 2 raised to power n subsequence. Correct? Count. In this case, your n value is 3. So 2 raised to power 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsequence that we have. So that's the concept of subsequence. I will repeat it again. Subsequence is a sequence that can be generated by deleting 0 or more element. Correct? Whether you talk in the context of a string or you talk in the context of array, everywhere it is same. So in array also, if I give you an array of length n, you will have 2 raised to power n subsequence of that array. Okay, now that's the subsequence part. Now let's come back to the problem. What they are asking, that how many unique subsequence of length 3 do we have that are a palindrome? Okay, now one simple solution of this problem, you generate every subsequence. For every subsequence, you check if the length is 3 and if it is a palindrome or not. If yes, then keep on counting. So let's say at the end of the day, if you have counted like there exist 10 such subsequence that is of 3 in length as well as also a palindrome, then 10 is your answer. But as you can clearly sense it, that if you go and try to do it, you will get time limit exceeded error. You see, look at this constraint. Your string dot length might range in this range, so from 3 till 10 raised to power 5. So in worst case, if they give you a string that is as big as 10 raised to power 5 in length, so if you generate all of the subsequence, these many work though you did at that point of time itself, 2 raised to power n, that many subsequence to be had. And if you generate all of it, your time complexity will become this, which is clearly not feasible. Okay, so if I cannot generate every subsequence and do something with every subsequence, then what can we do? In order to understand that how we are going to approach this problem, let's take this test case. Okay, let's talk about this string and try to find out how many subsequence of length 3 exist that is a palindrome. See, when it comes to length 3 and palindrome, only first and last character matters. Do you understand this or not? For example, this particular word here, madam, it is a palindrome because of 2 reasons. First character is same as last character, and in between also we have a palindrome. Do you understand this or not? A string is going to be a palindrome if and only if it satisfies both of its condition. First and last character should be same, and in between also we should have a palindrome. Now think about length 3. Think about length 3. In case of length 3, for example, okay, let's put it like this. Okay, for example, this particular string, does it matter what we place in between? No, it is always going to be a palindrome, because single character is always a palindrome. So no matter what you put here, if I put A then triple A, it is a palindrome. If I put B, then also it is a palindrome. If I put @ then also it is a palindrome, and so on so forth. So for length 3, what is present in between, it doesn't really matter. You can write anything. Okay, so you see how I am going to approach this problem. What I will do, for every symbols or for every alphabet from A to Z, I will try to figure out how many palindrome we can have in this string that is of length 3, and that also starts as well as ends with the same character. So when I take A, I will try to figure out how many palindrome of length 3 exist that starts with A and ends with A. Same I will do with B. How many palindrome of length 3 that starts with B and ends with P. Same goes with C. How many palindrome of length 3 that starts with C and ends with C, and so on so forth. And at the end of the day, I will just add some of the all of the numbers. So let's say that I got to know that for A there are 3 palindrome. For B there are 4 palindrome. For C there are, let's say, 2 palindrome. For D there are, let's say, okay, just a second. For D, and there does not exist any for E, any for F. Okay, let's say for all of these characters 0. So what is going to be my answer? 3 plus 4 plus 2 plus 1. These many palindrome of length 3, that is also a subsequence. I will tell you what do I mean by subsequence here in this particular context. Okay, it's no rocket science. Now that you already understand, this is going to be very easy for you to understand that why exactly we shouldn't be worried about the concept of subsequence in this particular case. I will show you. Okay, now let's try to think about it, how we are going to do. So first I will pick A. And I will try to figure out how many palindrome of length 3 exist that starts and ends with A. So in order to figure that out, there are couple of information that you will need. First, you are going to need what is the first occurrence, where is the first occurrence of A. Okay, so A is occurring at index 1 for the first time and at index 6 for the last time. Okay, how we will do it programmatically, how we will code it, that will come later. For now, please don't get yourself burdened with the code. Think and try to understand what is it we will be doing. How we will do it programmatically, separate a story. We will talk about it separately. Okay, for now I will figure out first occurrence of A and last occurrence of A. After this, the second information that I will need, that in between. So what do we have in between? We have 2 to 5. In this range, how many unique values do we have? So in this particular range from 2 to 5, how many unique character do we have? We have A, we have Z, we have X. These are 3 unique characters that we have. Do you understand this or not? See, A will also be counted. Okay, this I am talking about just this range. So we will be counting A also here. This range we will be counting A also, because in this range A is not being repeated. Now when I say unique, Z is also unique. It's just the second Z is duplicate, and then we have X. So there are 3 unique character in between. Now you see, at index 1 we have A, and at index 6 again we have A. If I wish to produce a subsequence of length 3, that is a palindrome, in between I can place anything. Okay, in between I can place anything. And how many choices do we have? We have exactly 3 choices. So when we place A, it will become AAA. And how exactly this AAA is going to be a subsequence? See, if I delete all of the symbols that are outside of my current observation boundary. So my boundary is from 1 to 6 only. I will delete every, I told you now, subsequence is a sequence that can be generated by deleting 0 or more element. So first thing that I did, I deleted everything that is outside of boundary, and then I will keep these two symbols at index 1 and at index 6. I will keep it, and in between I will delete everything, but I will keep a. So I will delete this x, I will delete this z, I will delete this z also. Okay, so all of these things are gone and we are left with a only. Now if I place z in between, then also we will get a palindrome. And how exactly this is a subsequence? Again, delete everything that is outside of the boundary, and in between you pick one z and you delete everything else. Okay, same goes with x also. In between I will delete everything, but I will keep x. Okay, so I will just keep x and I am going to get axa. Correct? So long story short, for every character from a to z, I will do two things. First, I am going to figure out first occurrence and last occurrence, and then for that character I will see that how many unique values do we have in between. Okay, so for a, first occurrence is 1, last occurrence is 6. And in between, so from index 2 to index 5, we have 3 unique characters. So with a you will get 3 palindrome, that is 3 in length as well as starting with a, ending with a. If we repeat the same process for b, so let's quickly repeat it for b also. Here please have a look. So first occurrence of b, okay, 5 6 7 8 9, first occurrence of b is at index 0 and last occurrence is at index 7. So what is present in between? The range 1 to 6. This is the range that is present in between. Now in this range, how many unique values do we have? We have a, we have x, we have z. That's it. Do we have anything else? A, x, z. That's it. So with b also we will get 3 palindrome only. See, delete these characters and we do not have anything on the left to be deleted. And then you delete all of this. So you are going to get BAB. Okay, if I keep x and I delete everything, so I will get BXB. If I keep z and I delete everything, then I will get BZB. You cannot argue that, sir, one time I will delete this z, I will keep this z, and another time I will keep this z. No, not like that. If so, you are going to get duplicates. Okay, so you see, if I argue like this, that delete everything, keep this z that is present at index 3, then I will get BZB. And then if I argue that delete everything but keep z that is at index 5, then also you are going to get BZB only. They are not different, they are same palindrome, and you need to count only unique palindromes. See, unique palindromes of length 3. So let's quickly start coding it now. Let's quickly solve it. And how we are going to code it, it's very easy to understand. Okay, if you have understood the process, code is very easy. First thing, how we are going to identify first and last occurrence. One simple solution, you run the loop. Okay, but then we are not going to do that. If I keep on doing it, my time complexity will be too high. If I run a loop on whole string every time for every character, that is going to be a very bad thing. Instead, what I will do, I am going to maintain a dictionary. So in Python term we call it dictionary, in Java we call it hash map. Correct? In C++ also I think we call it map only. Correct? So it's nothing but I am going to maintain a data structure that is going to store key value pair, where key is going to be the characters. Okay, so A, and now A is occurring for the first time at index 1. So this value I am going to store it like this. Please have a look. 4 5 6 7 8 9. So first occurrence of A is at index 1 and last occurrence is at index 6. Now for B, first occurrence is at index 0 and last occurrence is at index 7. For C, C is present only one time, so we are going to maintain it like this. Okay, D does not exist, so D will not be present in my map. E, F, everything is gone. After this we have X that is present at index 2 only one time. Okay, last occurrence, if you want you can store null, but I don't want to do it. Okay, I don't wish to do it. I don't wish to store null here. none. In terms of Python we call it none, in terms of Java we call it null. So if you want you can store null here or none, anything that you wish to, but I am not going to do it. What I will do, before I start answering, trying to figure out how many palindrome of C, I will first check that if the length of this array is 2 or not. If length itself is 1, if length itself is 1, that is this case, okay, C is occurring only one time. If length itself is 1, then I will just ignore. For this there exists 0 palindrome. If this string, this character is appearing only one time, then can it give you a palindrome of length 3? Of course not. It needs to occur at least 2 times in order to give you a palindrome. So I am going to prepare a map like this. Let's quickly prepare it programmatically. So I am going to have a variable. Let's name it my dictionary. Okay, my dict. So initially it will be empty, and then let's quickly fetch length of the string also and run a loop on the string. So for I in range of n, see, as we are coding, let's try to keep on debugging it with this string BBCBABA. Okay, BBCBABA. So here first thing, the character that we have is nothing but s of I. So when I value will be 0, ch will be b. When it will be 1, then again it will be b. When it will be 2, then ch will be c, and so on and so forth. Now if ch is not present in my dictionary, if ch is not present in my dictionary, in that case in my dictionary this is what I am going to place. Okay, please have a look. So currently my dictionary is empty. When b came for the very first time and it came at index 0, this is what I have placed. Okay, now if the character is already present, correct, for example next iteration when b will come again, so now this time character is present. So what I will do, I will fetch its value. Okay, so that is nothing but my dict of ch. Now in this case when my I value is 1 and when I will fetch this particular value, this is what I am going to get. Now you see length of this array is 1. What it means that before this b has occurred only one time. So the second iteration of b is at this index and I will just push it. So in my value I am going to append the second iteration and then I will update my dictionary. So my dict of key, that is nothing but ch, is nothing but this value. So when b will come for the second time, this value it will change to this. Please have a look. I had this array 0, in that array I have pushed 1. So now this is what my map looks like. Now c came, so again ch is not present in my dictionary, so this is what I am going to put. Now again b came, here see, I have made a mistake. This should go inside this if statements, that if length of my value is 1, if length of my value is 1, then only append it. If length of your value is not 1 but if it is 2, that is going to be the case this time when b will come again here. Now this time when I will fetch this value is going to be this. So in this case you see I will not touch my first occurrence, instead I will update my last occurrence. So before this b was occurring at index 1 for the last time, but now it will occur at index 3, correct? So I will just update this value. So here value of 1. Why value of 1? Because in my value array at index 0 we have first occurrence and at index 1 we have last occurrence. I will update it to I and then I am going to update my dictionary also here like this. So by the time this for loop finishes its execution, your dictionary should have been prepared properly. Let's quickly check it. Okay, so what I will do, I am just going to write return 0 for now, just to check if my dictionary is being prepared properly or not. So let's run the code. Wrong output, ignore it. I know that output is wrong. I am just interested to check my dictionary. So you see, it is saying that first occurrence of B is at index 0, that is correct, and last occurrence at index 5. C is occurring only one time, and A is occurring at index 4 for the first time and at index 6 for the last time. Okay, so I do have my dictionary in place. Now what I will do, for every character from A to Z, I told you now that for every character from A to Z, I will figure out first occurrence and last occurrence. Okay, that I will get to know from my dictionary, because my dictionary is storing my first and last occurrence. If it exists, if first and last occurrence exist, then it is storing. Okay, and after that, in between, I will try to search for unique values. Okay, so for every character from a small a to a small z, how can you run a loop like this that goes from a to z? Here, please have a look. In Python, you can do it like this: for I in a range of 97 to 97 plus 26. Okay, why I did it like this? Because for a small a, ASCII code is 97. Okay, so here the character that we have, I will convert my I into char. I think you must already be knowing about ASCII values, correct? Every character has a corresponding integer to it. A small a is having an integer 97. So when I convert that integer into character, I will get a. Okay, I am going to print this ch, and let's see if I get from a to z or not. Okay, a b c d e f g and so on so forth till z. Okay, so same thing we are going to do here also. Please have a look. For I in a range of 97 to 97 plus 26. Okay, what is the current character that we have? Is nothing but chr of I. So initially it will be a, then b, and so on so forth. And for any character, I will try to solve only if that character exists in my map. Okay, for example, you see, for this string itself, the string that we have in our test case. So what is that string? Double B C B A B A. Double B C B A B A. My map will look like this. B is occurring at index 0 for the first time, at index 5 for the last time. C is occurring only at index 2, and A is occurring at index 0 and index 4. So you see here, sorry, at index 6. I am only going to solve for B and A. Rest every other character I will ignore. So D is not present in my map, F is not present in my map, and so on so forth. So for those characters, you are not going to get any palindrome, because the character itself is missing. So see how I am going to write the same thing programmatically, that if ch is not present in my dictionary, okay, in that case please continue, don't do anything. Okay, if ch is not present in my dictionary, then please continue. Or if ch is present, for example, in this case, C. If ch is present and length of its value is 1, in this case also I will not try to solve for C. Why? Because it is occurring only one time. There is no way it can give you a palindrome of length 3. Correct? So here itself you can write one more condition, that if ch is either absent or my dict of ch, okay, so length of this particular thing, this is an array, okay, if length of this thing is 1, in both of the cases you please continue, you don't really need to solve it. But if we need to solve it, then how we are going to solve? Try to understand in the case of let me keep on dry running it for this test case itself. Double B C B A B A. Okay, here double B C B A B A. So my map will look like this: 0 5 C 2 and A 0 6. Correct? So first thing that I will do, that if my character is present in the map and length is also not 1, if it is 2, for example, when your I value will be 97, your ch will be A. So the value that I am going to fetch for this particular character in case of A will look like this. Okay, so this is the value, this value array, it will look like this. I will fetch the left index and right index like this here. So my left index is nothing but value of 0 and my right index is nothing but value of 1. Okay, like this. Now in between, so from the index left index plus 1 till index right index minus 1, I need to count how many unique value exist. Okay, so for j in range of li plus 1 to ri, okay, li plus 1, we need to look in between. So if my left index is 5 and right index is 10, so I wrote 6 comma 10, so it will start from 6 and it will go till ri minus 1 only. Just in case you do not know, range method goes from a start till end index minus 1 itself. Okay, and to store the unique values, I am also going to have an array. So here the current character that we have is yes of j. If yes of j is not present in my array, if not in my array, then first thing that I will do, I am going to push it to my array and then I will increase my unique count. Okay, so do we have any variable here? So in order to store insert, let's have a variable that will be initialized with 0, and every time I start counting, I am also going to have a variable count that will be initialized with 0, and every time I encountered a character that I haven't encountered before, I will first increase my count and then I will put that character in my array, so that when I encounter the same character again, I know that this character I am not encountering for the first time. Okay, so I will keep on counting, and by the time I come outside of this loop, in my count variable I have unique count in the range li plus 1 till ri minus 1. So the same count I will add to my answer. Answer plus equals to count. End of the story. Okay, so a is occurring at index 1 and first time, and at index 7 last time. From index 2 to index 6 I have 5 unique character, so with a I will get 5 palindrome, and so on so forth. Now if I execute this code, I should get the correct output. Let's quickly have a look. Okay, if I do not get the correct output, then we will see what went wrong. Okay, let's try to submit it. Bingo, it got accepted. Okay, so I hope this video was helpful to you. Again, if you have watched the video even without trying on your own, then that's very wrong. I will suggest that you first go and try it on your own, and then you come back here and watch the solution video. Now if I was able to help you, then you can consider subscribing my channel. On this channel I am going to produce continuous videos now. Okay, so every day you can expect one video from LeetCode, and also real soon you can expect videos on web development stuffs also. Okay, so we are going to develop mini web project using vanilla JavaScript. We will also be developing major projects using React.js, and then backend services using a Spring Boot, and so on so forth. So everything I have learned in my life I will teach you. So if you stay subscribed to this particular channel, I believe that it is going to help you a lot as you grow in your career. So thank you very much for being here. I will see you again in the next video. Bye guys.